Look at the third page. We are going cliff diving. So to clear the rocks, you're going to need to take a running jump off the cliff, and the equation is, and this is in, the y-axis is in feet, and the x-axis is in seconds. The equation is negative 16x squared plus 16x plus 60. So the first question asks, how tall is the cliff? 60 feet tall. How come? That's the y-intercept. That's what you get when you plug in 0 for x. At 0 seconds, you're 60 feet high. Okay? So 18, when are you going to hit the water? How would we figure that out? We want to know, when does this equation equal 0? Oh, we know how to do that. Either you factor, you complete the square, or use the quadratic formula. But is there any way I can make this easier? I could times by -1. That'll get rid of the negatives. That's good. I could also, I could divide by 4, or we could do both by dividing by -4. So that would give me 4x squared minus 4x minus 15 equals 0. Now, when you solve that, you're going to get two answers, right? Every quadratic has two equations. Does the answer to this question actually show up in two places? Can you hit the water twice? Not unless you bounce. So, what do we do with the other answer? How do I know which answer is right and which answer is wrong? Only the positive answer is going to make any sense. If I draw this parabola, this answer over here, I don't know what it is, -3 seconds. That doesn't make any sense. Somehow, you dove through the rock 3 seconds ago and reached the cliff at 0 seconds and then flew up in the air and then out and hit the waters. So this is another instance where this number makes no sense in the story. But is that number important? Yes. Why? Because the next question, 19, asks, when will you reach your highest point? How do you find that? It's the middle of the two roots. So I don't know, maybe that's 1 second after you jump. Okay, the next question asks, how high did you jump? How would you figure that out? So let's say that I figure out 1 second is the middle point. Then I plug 1 into x. Should I put 1 in here? Why not? That's not the equation that represents the path. That equation is only useful for finding the roots. So you would plug 1 in here. Let's say I plugged 1 in there and I got 68 feet. Is that the answer? Check number 20. How high did you jump? Is the answer 68? If I plug in 1 and I get 68, now I don't know what it is 68 the answer? Did you jump 68 feet high? No. You only jumped 8 feet because you already started at 60. So that question is not asking for the maximum. It's asking how far did you jump from the cliff to reach the maximum. Okay, 21 is asking, how long did it take you to rise back to your how long did it take you to rise to your maximum height and then fall back to the same level as the cliff? If the maximum occurred at 1 second, how long did it take to go from maximum and back to 60? It would be 2 seconds because this is a symmetric graph. Okay? Now, the last question is a little bit tricky. How far did you jump? Well, if 4 people jump off the cliff at the same time traveling different speeds, who hits first? They all hit at the same time. So in order to figure out how far you jumped, you need to know how fast you were traveling when you left the cliff. So number 22 says, If you traveled 22 feet per second, how far did you jump to clear the rocks? How do you use that number to figure out how far you jumped? You would need to know this route. So let's say this is 4 seconds. If you were in the air for 4 seconds, how far did you jump horizontally? Well, rate times time equals distance. Do I know the rate? 22 feet per second. Do I know the time? 4 seconds. So I would times this by 22, and I would get 88 feet. Now, none of those numbers are right. You're going to have to figure out what the numbers are. 4 seconds is the root. Well, whatever the root is for the original equation tells you how long you were in the air. Okay. All right, turn the page. Okay, this is kind of a tricky, this is a tricky situation. You have a photograph that's 8 centimeters by 12 centimeters. So we'll call the little photograph photograph A and the big photograph capital A. If you want to make this picture bigger, and we're going to do it in a weird way, we're going to increase the height by the same length that we increase the width. So we're not making it like twice as tall and twice as wide. We're making it a certain number of centimeters taller and a certain number of centimeters wider, and it's the same amount. Okay? And we know that the new photograph is twice as big in area as the small photograph. So what is the area of little a? Yeah. What's the area of the original photograph? 96 centimeters squared. What is the area of the new photograph? Double that, which is 192 centimeters squared. Well, I want to know, in order to double the photograph, double the area, how much bigger this way and how much bigger that way do I need to make it? And we know that those two distances are the same. So let's call them x. They're both x, whatever x is. How are we going to figure out how to calculate x? Well, I know that the area equals 196. So can you use the picture to calculate the area? What is this distance here? X plus 8. So x plus 8, what is that length? X plus 12. And I know that x plus 12 times x plus 8 is equal to 192. Okay, are you guys good at multiplying these in your head now? X squared, that one and that one would make, so 12x and 8x turn into 20x, and the last one's going to be, so plus 96 equals 192. Can I solve this? Well, I would have to subtract the 192 over, which is x squared plus 20x. So if I subtract 192 from positive 96, I get negative 96. So that equation equal to 0 will give me the x values. Now, this is an x squared, so I'm probably going to get two answers. Does it make sense that this would have two answers? Maybe, maybe not. How would I know if one of the answers doesn't apply? If it's negative, that would make the area smaller. So if both of your answers are positive, it means there are two ways to do this. If one is positive and one is negative, then there's one way to do it. What if both answers are negative? then there's no way to do it. What if your answers are imaginary? Then there's no way to do it. Okay? So, find the roots of that equation, and that will tell you the answer to 23. 24 asks, what are the dimensions of the new photograph? So let's say x is 10. What would the new dimensions be? 18 by 22. And then 25 asks about distortion. 26 asks about perimeter. 27 asks about perimeter. 28, the area of the picture doubled. How much did the perimeter increase? So if I had, let's say I had 24, and I increased that to 40, how do you find the percent of increase? The other way around. So you would want to do 40 divided by 24. How much did that increase? Did it increase 166% or did it increase 66%? Well, we started with 24 and we ended with 40. So we increased 66% because we only went up 16, right? So 16 out of the original 24 is an increase of 66%. So this 1 represents the original 24. So we are 66% above the original 100%. Okay? And then you have to do the same thing with the diagonals. How would you calculate the diagonal of the original? What formula would you use? Pythagorean theorem. Okay? All right, get to work.